All right, for number 11, we are asked to find the inverse of this function, and then we're supposed to graph the function and the inverse. Okay, I'm going to start with finding the inverse. When I find the inverse, first of all, let me do something. I don't like working with this f of x, so I'm just going to write it as y equal 2x minus 3. Now, there's only two steps to finding the inverse, and I've written them down below. What I need to do to find the inverse is to switch the x and the y. So where I see the y, I'm going to write a x, and where I see the x, I'm going to write a y. And then I'm just going to, leave everything else the way it was. You don't switch the whole terms. You just literally pick one up and put it where the other one was, okay? So now what you got to do is solve for y again. So in order to do that, you can add 3 to both sides to get the y by itself. And now you've got 2y equal x plus 3. And then to get y by itself, I can divide everything by 2. I'm going to put a little invisible 1 up there. And as I cancel out the 2's over there, I'm going to write my y over here. And so that ends up being 1/2 x. I can write it this way instead of just the way it was up there. And then plus 3/2. Now, one thing you might notice about both of these functions, by the way, this is the inverse. We could write this as f inverse of x is equal to 1/2 x plus 3/2 if we want to. We could do that, and that way it would really specify that this is the inverse of what I started with up here. All right, so if you notice, both of these are lines. They're both in the form y equal mx plus b. Let me write that one above the top one. Y equal mx plus b. So we have a y-intercept of -3 for the original. And then you count, the slope is 2, so that's rise 2, run 1, or up 2, right 1. Up 2, right 1. This one's easy to graph, isn't it? You can go down 2 to the left 1, down 2 to the left 1 to get some good points. And let me just try to connect that as best as I can. I always have trouble on this iPad because I can't use a ruler. Okay. That's the original. Now I'm going to graph the inverse in green. Now, think about graphing this inverse. This is also y equal mx plus b, right? But your y-intercept is 3/2. That's like 1.5 up here. It's kind of hard to graph if I'm going to count up 2 over 1. I can do it, and there's nothing wrong with doing it. But here's what I'm going to do just because it's easier. And I'm trying to write on this iPad and the stylus, and the iPad don't always connect the way, it doesn't always pick up the tip like I want it to. Okay. So here's what I'm going to do. I've got some points on this blue line. Do you remember that one way to graph the inverse is to take some points and reverse them? And then you can graph, if you flip the x and the y on the original, that's the graph of the inverse. So for instance, my y-intercept on the blue line was 0, -3. If I flip that, if I come down here and I flip that to get a point on the inverse, that would be -3, 0. So that would be right here. Okay, let me find another good point. I see a point here on the regular line of 1, -1. If I flip it, it would be -1, 1. So -1, 1. Something is not right here. I've messed up something. 0, -3 would be -3, 0. And then x is 1, y is -1 would be, oh, I see, I put it in the wrong place. -1, 1 would actually be right here. Okay, so I'd have something like this coming in for my inverse line. Helps if you graph a point right, doesn't it? So that stray point there was in the wrong spot. All right, that is the green one is the inverse, the blue one's the original. How do I know that this is right? Well, if you remember, there's supposed to be reflections around the line y equal x. And so one thing you could do, if you were looking at your calculator, you could put in this equation, y equal 2x minus 3, this equation on a different line, and you could even put in the y equal x on a third line, and that y equal x, once you put it in, those two functions, those two lines should look like they're reflected over the line. I'm going to draw my line y equal x in red. So the green and the blue line should look like they were flipped across the red line when I get done here. Well, the line y equal x has points on it like 0, 0, 1, 1, 2, 2, 3, 3, -1, -1. The y and the x, they match, okay? Let me try to graph that in there. There's 1, 1, 2, 2. Let's go down here, -1, -1, -2, -2. And of course, now you got to keep in mind, graphing skills on this thing are not great. Does it look like they were reflected across there? It does. We know that one's done correctly as maybe not great as it is, but it's done correctly. Because it looks like those lines are flipped around. The blue and the green look like they're flipped images, reflections of each other over that red line y equal x. I'm going to do number 13 just because we haven't done a lot of graphing cubes, and I want to show you what you would do. Okay, so you don't know much about cubes. Is that a big deal? No. Because what you can always do, let's say we're going to graph this one first. Get this straightened out. I'm going to graph this first. Let me pick blue to graph it in, okay? What I can do is I can make a table of values. You can always graph from a table of values if you don't know, something about a function. And I'm going to put in some good values. I'm putting like -2, -1, 0, 1, and 2. So if I cube -2, I get -8. If I cube -1, I get -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. You could get that off your calculator. I know I'm going fast, but I don't want to use up a whole lot of time just because I'm trying to fit all this on a video before the time runs out. Okay, so -2, 8 would be here. Okay, let me turn off the recorder and graph this. Before I turned the recorder off, I realized I was graphing stuff in the wrong quadrant. It's summertime and it's the first thing in the morning and I'm not awake yet. So I corrected it. So see, I connected the correct points. You'll see some stray points on there. They're not correct. Okay, now if I want to graph first of all, does this have an inverse? If I do the horizontal line test, I see that I'm only going to hit 1 point, and that's how I know that there's an inverse. And I'm not going to draw that on there since we're going to have a lot on this graph, but you can imagine just taking your pencil and doing the horizontal line test instead of the vertical line test. So what would the inverse be? Let's do that work in red, and I'll make a table of values in red down here for the inverse. Now remember, I could have written this as y equal x cubed, so if I do that and then I say, okay, let's do our inverse. We switch the x and the y, and then we solve for y. How could I get y by itself if it's got that cube on it? Well, I could cube root both sides. And I end up with y equal cube root of x, which, I could write it. Let's change that to the inverse notation. This means the inverse of f is equal the cube root of x. Those two statements are the same, but this is how you might want to write the inverse. Okay, I could graph this by a table too. I could plug some points in, but why would I want to if it's so easy to graph the inverse by just taking the points that are up there in that blue table and flipping them? So I'll have -8, -2 if I flip the first point. If I flip the second point, it's just -1, -1 stays the same. 0, 0 stays the same. 1, 1 stays the same. But if I flip that last point, I get 8, 2. You see why it's important to pick more than just maybe 3 points? Because you would probably not get the sense of this graph if you didn't plug in more points. All right, I'm going to turn this off and I'm going to graph the inverse in red so that I won't run out of time. Now, when I graphed that and connected it, I didn't do a great job because it really should have more of an S shape to it. I kind of had trouble looking at that sideways and connecting it. This probably should have been more up like this. So, you could improve upon that graph I drew. Now I'm going to draw in the, this is pretty much correct, though I could have done a better job, especially with the red graph connecting the points. You could always put this on your calculator and look at it, and it would be a lot better representation. Now I'm going to put in the line y equal x because these two graphs should be reflected around the line y equal x because they're inverses. So remember, that's going to have points on it like 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, -1, -1, -2, -2, -3, -3, -4, -4. I'm going to turn this off and graph that. And now if you look at that line, y equal x, it does look like they are kind of flipped around that line. Again, your graphing calculator would give you a much better picture. I'm just really limited with how well I can draw these on this iPad, but at least it gives you a general idea of what to do. So this is how you would do that. If you have something you don't know how to graph, make a table of values and get the shape of it. Make sure you put enough points in to get the shape.